FDP. And today we will be having the first lecture by Dr. Arun Dayal. Let me briefly introduce him. So Dr. Arun Dayal is a faculty in the Department of Mechanical Engineering at IIT ISM Dhanbad. He has more than 15 years of experience in teaching robotics, automation, and CAD. He obtained his PhD from IIT Delhi and master's in mechanical engineering from BIT Mishra, and he worked on the basically the robotics area in both the areas. In during the MTech, he worked on the biped, and during the PhD, he worked on the force analysis of the uh, arm, basically manipulator arm. Before this, prior to this, he worked at Anglo-Eastern Ship Management Company, Hong Kong, for almost 4 years as mercantile marine engineer. He has published papers in various peer-reviewed journal and conferences, and he has co-authored two books. Basically, one is on the computer graphics, published by the McGraw-Hill, New Delhi in 2008, and another is on vision-based identification and force control of robotics, industrial robots, published by Springer in 2022. Along with the faculty at IIT ISM, he is also the director of the Aduja Robotics and Automation Private Limited. He is handling more than 3.5 crores project in the field of the robotics, funded by the various funding agency, including the Defense, Government of India, etc. He has also given lectures, NPTEL lectures, basically NPTEL courses he has floated. One is on the industrial robotics, theories for implementation and collaborative robotics is the another one. So with this brief introduction, I request Dr. Arun Dayal to deliver the today's lecture.
Thank you, Professor Vijay. So, yes, hope all of you are here. Almost 60 participants I could see. So, nice
Yeah, maybe
introduction.
some of them may be joining late.
Yeah,
We are expecting more.
yes, so all of them are online. So, I
Yeah,
hope,
online.
yes,
This
yes,
is online
it should
everything.
be a bit two-way communication also. So, I would
Yeah,
encourage everyone to participate. Stop me anywhere in between if required. Okay, and we'll be discussing rather this gripper as such is not a very big topic, but still quite a lot of research has been done since long, a few by me also recently. And yes, so while doing so, I have few immediate thing that I want to show here. Okay, so this as such I'll be covering on grippers for robotics. Grippers commonly known as end of arm tooling also. End of arm means if it is a arm or maybe a parallel manipulator kind of, so it attaches itself to the end of the arm, right? So that is why this name is there, that is end of the arm tooling. Okay, we'll have some emphasis on selection guidelines. So most of us will not be designing a gripper. At times we may be, but yes, we'll mostly be selecting a gripper for a specific purpose. So we'll emphasis on selecting guidelines for this, how we should go for selecting a gripper. We'll discuss quite a lot on yes, just a sec. So we'll discuss different types of gripper. Before we could select, we should know what are the options that we have in our hand, right? So for that reason, I'll be covering quite a lot of type of grippers which are there normally available in the market. Before discussing the guideline, I'll also go through a few data sheets. Now being an engineer, you should have a habit of going through the technical data sheets, what the data sheet says, not just being an end user for a particular commodity. right? It is always advisable to go through the data sheet of that. I'll go one or two of them for the grippers that I'll cover. So based on that, I'll provide some guideline for selecting a gripper. Force analysis, definitely if I get time, I'll go through force analysis, basic gripper systems, right? Gripper design consideration, if at all you want to design a gripper for any specific purpose, right, we'll see some design, what should be considered, we'll have some notings on that, and latest development in the field of gripping and grasping, okay, two things are there, we'll come to know very soon. Discussion on technical data sheet, I'll show some example videos, quite lot of videos rather, right, and journal paper, few research papers I'll discuss, right, so as to help quite new researchers who want to venture into this kind of robotics, right. So as such, what is a gripper? Gripper is a device that enables holding an object that needs to be manipulated. Manipulated here I mean you want to transfer from one place to other. So that is the reason you want to hold it first of all, so that it can be manipulated. So how to hold it? So as such, just like our arm, no, you have a dexterous gripper at the end, your palm, your fingers, that help you to grip something, to hold something, right. So your arm terminates with the end effector tool that is commonly known as gripper if it is used to hold an object, right. So we'll quickly start with a small video here, okay. So before to that, yes, yeah, just a sec. Okay. So you just watch this video, what it is trying to say. This is a video by one of the manufacturer, that is SMC, that's a Japanese company. India also it manufactures gripper, few of its types in Noida, right. So that is there. So just watch this video, that is for few minutes, yes, 1 or 3 minutes. You see it is a grip, ensures precision and a tight grip, high repeatability gripping force C. What it is basically, it is a two fingered gripper with repeatability 0.01 mm. So just look at the key terms which are here, okay. Before we could elaborate upon how to go for gripper theoretically, just watch this video carefully. This is the first video I would like to show because it covers widely on all various types of gripper, okay. So that is the reason what precision means here, what is repeatability here. Repeatability is 0.01 mm. It is not the robots and effector repeatability. What is repeatability? Anyone, if you can stress upon that, what is repeatability here? Anyone? It should be two-way communication, as I told you. No? Okay, I'll elaborate. So let's say if it is an end effector arm, what happens? So every time you touch upon something, no, you go repeatedly to a multiple visits to the same site. Every time you reach there with some perturbations, right. So maximum amount of perturbations from the commanded position. So the sphere which contains all the dots which you have touched upon for a given commanded position, the maximum size of that can contain all the dots is its repeatability. There are ways to measure it. There is standard ISO 9283 that does in terms of robots. So in case of grippers, it is very much the same. So repeatability here 0.01 mm plus or minus, that means it can grip with that much of repeatability, right. So its fingers cannot go more than 0.01 mm here and there. So you can precisely position command your robot and your finger can easily grasp that, okay. So that is one, and then let us move ahead. So what kind of gripper over here you can see? Here you see it is a two-fingered gripper. It has two fingers. That is quite good enough for quite lot of type of grippers that we will find here. Okay, so quite lot of jobs that can be done with just two fingers. Okay, you don't need a palm or a multi-finger kind of gripper. Okay, so this is a two-fingered gripper. What else have you noticed here? This finger is not flat ended, it is maybe a spherical cut. If you can see me closely, so it is a spherical cut so that it can grab cylindrical object. Okay, cylindrical object. So if the radius is fixed for that cylindrical object, you can have a fixed shaped cylinders cut on the fingers. Okay, listen very carefully. So that can exactly fit on the surfaces well. With multiple point contact it will establish, and it can establish pure gripping, and there won't be any kind of slipping, right. So that is the reason it is cylindrical cut. If at all it is of, okay, let me stress upon this point what I am trying to stress upon here. Okay, so if it is a circular object of this kind, okay, if it is a circular object, so you can have a gripper of this shape, okay, with some radius for this surface. Okay, so this surface will have some kind of radius. Okay, and this has a radius also. This is R1, this is R2. If there is a bit of difference between them, there has to be some, but that should ensure maximum amount of gripping surface so as to avoid any kind of slipping over here. Got it? So it is a cylindrical cut. So if the radius is of multiple sizes, you have cylinder of this, you have cylinder of this, so you have multiple size cylinder. In that case, what we should do here, hope you are here with me, so continue listening. Okay, create noise. I like noise.
Yes, sir. Yes, sir. Yes, sir.
Okay, create noise. I like noise also, and that makes me feel that you are alive. Okay, so yes, so this is cylindrical surface. It can establish good amount of surface contact over here without slipping. Okay, but this could be a wedge kind of gripper on both the sides. Okay, wedge kind of gripper on both the sides. What would be the benefit of this? Now you can hold cylinders of multiple sizes. It is not, right. We can have cylinder here of multiple sizes, and as because both the wedges are of same type, same size, it will be self-centered also. That means when you approach from both the side equally, so upon full closure of this on the surface of the cylindrical surface, so this center line will not vary. The center line of this cylindrical object will not vary, right. So you can lower the gripper, hold it, and upon holding this object will not shift on either side, right. So that is the beauty of this having both side wedges. Okay, so yes, but this has got a problem. This establishes 4-point contact. Mind it, again you are with me, this is 1 point, this is second point, this is third, this is 4 point. So is it okay to have 4-point contact for a circle? 1, 2, 3, 4 for using this kind of wedge. What would be the problem having this kind of 4-point contact? A circle can be defined with just 3 points, 1, 2 or any of this. Okay. Fourth one is redundant, is it not? So if at all it is not precisely placed, it goes off the surface and creates some spacing over here. Okay, there will be some space left over here. This will cause movement of your cylinder, right. So 4-point is redundant, but having wedge on both the side ensures it is self-centered. That means the axis will not shift. Got it? So let me wipe off a bit so as to make some space. Okay, So that is the problem with 4 finger 4 point contact, but yes, that ensures self centering. Okay. Now what else could be done? One of the finger can now be like this. One of the finger can be flat, other one can be like this. So upon holding any cylindrical object, it will create 3 point contact, one here, other one here, other one here. This will precisely hold a cylinder, right. But again, what is the problem with this? With varying size of cylinder, if the second cylinder that you are holding is little smaller, upon holding it will shift the center line. Got it? If you try to hold it, okay, this object will be shifted. Center line for different sized cylinder will be different, but in this case it was all the same. This was 4 point contact, this is 3 point contact. Center line shifts. In this case, center line remains, right. 4 point coin, one is redundant. So you saw now, this is some practicality of having a gripper. Okay, having a gripper of different faces. Even for a 2 fingered gripper, now you assume, right. So you have to design specifically for a purpose, right. So even just holding a gripper, just holding a cylinder, you have to consider so many things, right. How much is the perturbation in the surface, so that you can easily use 4 point finger, 4 point contact 2 fingered gripper, or maybe a wedge of one side flat, other side wedge kind, right. So this has got its own problem. So now you know little bit of practicalities. There are many. Surface could be circular, surface could have a soft surface. This may be, these two flat fingered gripper can be fitted with flat surface also. Got it? Flat surfaces with some rubber surface, so as to avoid any slipping. So these are things which are to be considered. Okay. So let me just again switch on this video and continue further this discussion. On this video, we'll elaborate many things that you see. We have discussed repeatability, we have discussed point contact, 4 point contact, 3 point contact, holding a cylinder with cylindrical surface, having a adhesive or maybe a rubbery surface. What is the benefit? So that will help you to choose kind of surface you have, okay, the kind of object you have. So now you know what all things that you have to consider. I have discussed a bit, I will keep on discussing. So the aspects that we have discussed so far is repeatability, point contacts, 3 or 4 point contact, cylindrical surface for circular kind of object, right, wedge contact, wedge and flat contact, right. So various things we have discussed. I will keep on recapitulating also. So let us move on. So this is cylinder, right. So now it goes, what is this? This is a 3 fingered gripper. This is a 3 fingered gripper. If you remember the chuck of your lathe, what was that? That was self-centering chucks were 3 fingered. Otherwise you will have to bolt all 4 of them independently and have a scriber to mark, so that you establish the center line of the lathe tool, right. So that is what you did. Maybe in the workshop technology first year of engineering you might have done it. So a 3 fingered gripper ensures self centering. So if you require strictly self centering grasp, so in that case you use this kind of gripping, that is 3 fingered gripping. So this ensures that. Okay. Keep noting. So you have various kinds, right. Common use, this is surface with flat fingered gripper with 2 point, 3 point, 4 point, or maybe rubbery surface or a cylindrical surface, 2 point gripper. Second one is 3 point gripper, Fourth one is a flexible gripper of wide opening. Third one can hold from inside, right? Fourth one can hold from inside. So there are various types of gripper for different purpose. Okay, this is just a few. I have list that I will be discussing over. So this is how it works. Okay, and then you have angular gripper for limited space. Normally, if at all it is a fork kind of gripper, you have a long prongs, right? Just like a tongue which doctors have it, or maybe surgeons they have it. No, you need a wide space, a long space to hold any object. In case you don't have much space for that, what you can do, you can have this fin kind, right? You can grab it like this. So this is angular gripper or a radial gripper for limited space, that again can grip like this. You got it? What it did? Got it? I have just repeated it. Okay, now another type, that is magnetic gripper. Obviously this is only valid for ferromagnetic pieces, right? So uneven surface or any kind of surface can be held firmly. Electromagnetic gripper, this is quite obvious. Adapt to special environments, right? Some special kind of gripper. Okay, dust and water resistance. So this is also to be considered. We'll discuss in detail how much ingress protection in terms of dust and water it should allow. There are grippers for clean room. What is clean room? Where ICs chips are assembled. Even for space station precise assembly spaces, you need to have clean room. It is not clean literally, it is actually number of particles in 1 meter cube. It can be class 100, it can be class 1000 clean room. So that is mostly used for electronic industry, right? So it is that clean room. You can Google around and find it out. So it is for that reason. It cannot spread around any kind of particle in the air. It is not, it is very sensitive to that. So it is used in electronic handling. Okay, clean room. There are grippers for special purpose like battery manufacturing, which is safe for copper, nickel and zinc handling. Okay, chip handling, you see, pick and place. This is a typical pick and place task. Okay, end of arm tooling it is known as, right? These are grippers which can hold from both the sides as well as it can rotate about its axis. That means it has 2 degrees of freedom. First is the gripping direction, lateral, both the fingers are not independent. Although it look like 2 independent degree of freedom on each finger, but actually they are clubbed together. So that is 1 degree of freedom, and another one is axial degree of freedom, axis of rotation, 2 degree of freedom. You see, it can rotate, it can hold. This can hold from outside. It looks like a pneumatic gripper. I'll tell you what is there inside later on. Okay, this is multiple fingered gripper which can hold pair of things together. Angular gripper, parallel gripper, you could see different usage of that. All the gripper fingers are specially designed, you see, right? And you can have a same robot arm with multiple types of gripper. You saw in the next one, it rotates and different type of finger comes forward, right? Tool changer, actually it is changing the tool. So if you go to the assembly line, you will find multiple types of gripper on the same assembly line, right? So you saw many. So let us stop this video here and continue further. Okay. So hope you got the idea what we are going to discuss now with this video. Okay. So now a parallel gripper based on the how different types are defined here based on the primary motion of the gripper jaw. Okay. So let me just turn on one small example once again. Okay. Okay, before we continue, we'll just see different types of gripping mechanisms here. So what we are about to discuss now is changed like a angular gripper in relation to the gripper body, right? Advantages are they are very accurate because it is just 2 degree of freedom mechanically controlled, so they are very precise, very accurate, right? They are simple, easy to maintain, quite inexpensive. If at all you want to do, quite lot of job can be done with this kind of two fingered gripper. It is widely used in the industry, most widely used. Mostly they are run with electrical solenoids. You have magnetic force built up using magnets over here which moves the gripper. It may be spring loaded, so you pull this finger out using magnetic force and it comes back to the place using spring force, right? So you have two of them, such pairs are there, or it may be a pneumatic piston. You have cylinder over here, pneumatic cylinder, just like your hydraulic brakes which are there inside your drum, okay, inside your maybe a disc brake kind of, right? So you have such small pistons which is pushed outside to move this fingers. It can be hydraulic, it can be pneumatic, both are fluid operated with pistons, or maybe 4-bar mechanism kind of like grasp mechanism. I will discuss almost 20 different kinds of mechanism that quickly you can see that in a video. Twin rack and pinion kind of arrangement or a wedge system, okay, or a wedge kind of system. So now again let us quickly watch this another video, okay. This is 4-bar mechanism. Inside you see there is a 4-bar and one of the link is actuated. One of the link, blue color one, is actuated using a piston. So it is just 1 degree of freedom, right? If you calculate degree of freedom of a 4-bar mechanism, it is 1. So now that two 4-bar mechanisms are paired here, both are connected with a single piston, this pink one. So overall this gripper is a one DOF, right? So it goes like this, okay. So problem here I find is when it is gripping, it is also coming a bit forward, right. So you have to hold a particular distance while holding something which is kept on the table. If you try to grab it, it also comes a bit forward, it may hit the table. So you have to be a bit careful about this, right. It is coming forward, you see. Okay, second time, this is, you see inside it is a pinion, right, rack and pinion. Again it is 1 degree of freedom, both the jaws move evenly to both the sides. This is wedge kind of, wedge, okay. Again it comes back to its position using spring loaded mechanism and pushed outward using the wedge. All these are one-off system, right. There are many approaches. In this one you see when the fingers move, they don't come forward or go backward, right. It traverses only in one direction, right. That is the beauty of
మేడం
this.
డిపార్ట్మెంట్ లేదు నన్ను చెంబరలేదు అది వెళ్ళిదిరండి నువ్వు
Yeah,
వెళ్ళిదిరండి
someone can please mute yourself when
ಬರ್ಲಿ
you
ಹೊರಗೆ
talk.
Kindly unmute you.
ಆಯ್ತು
Oh, mute yourself.
Okay, so this is another mechanism. You see there are all these are intuitive, quite intuitive. Just see the, keep seeing the animation of it. Mostly they have 4-bar mechanism inside, you see, or rack and pinion type of, right. So if you have to design, you may pick up one of them and go ahead, right. This motion, linear motion, can be done in different ways, but you see in the pink colored one, this pink color one is moving. Essentially this can be moved using electromagnet, hydraulic force or a pneumatic force. Each one has their own advantages, disadvantages. We will discuss in detail also, okay. You see it is aligning itself. You saw just now when the grippers held at both the wedges, the cylinder moved a bit and it came to the center line. This is interesting, it holds from a different direction altogether. Movement can be done using solenoid. Solenoid is used in your ding dong bell, right. Pneumatic syringe you can use. This looks quite complex, but yes, it is 4 finger or a 3 fingered one. This is 5. You can keep on expanding it. You can hold it, you can envelop it from multiple direction. So object of random shapes can be held using this. This is quite complex, unnecessarily though. This is all because they want it to be self-centering one. Got it? Okay, we'll continue now with our slide then. Okay, so now again, there are many small videos which are there that I have created a library for you, so that you can always go through. This lecture is getting recorded, so no problem, you can always watch it later also. I can move a bit or maybe remove myself for that reason, okay. So yes, now it is recorded, so you can come back to this location and post this on your browser to see this videos also. Okay, so this is different types of mechanism that you have seen now. So these are a few 4-bar mechanism kind of, right, twin rack and pinion kind of, piston kind of, right. Piston can be air driven or it can be hydraulic oil driven, right. Air there, that is having its own advantage, it is naturally cushioned. That means if at all objects of different sizes comes, it will automatically assign itself, right? It will automatically take the shape, right? Shape means size essentially. So the dimension, changing dimensions, it will automatically get adapted to, because it is cushioned. So that is the beauty of that. If at all it is holding a glass, it won't break it, because it is some air cushioning is there. In case of industrial, the air pressure can be controlled. It can be 6 bar, it can be 8 bar, 10 bar, depending on the pressure that you want to put to that object, right? It can be electromagnet also. Again, electromagnetic forces can be controlled by controlling the current flowing through the solenoid, right? So that is the beauty. Instead of having a servo mechanism or a motor of high torque, so that is avoided in case of gripping. Normally air is used. Hydraulic oil, that is used for firm gripping, but that is not compressible. So that is the reason it is very risky to have it, right? And you see, you can have a twin sliding fingers with a wedge kind of. This was wedge surface, this is pinion. So four major kinds of, with different kind of mechanisms you saw, right? Moving ahead to this, so you saw angular gripper also. I'll just quickly go through this once again. Okay. So again, look it very carefully what want to show you here. So this is a 180-degree air gripper. 180-degree means the gripper will open up to 180-degree. So it completely clears off the surface where it is attacking. Okay. So outside it looks like this. This is from SMC, Japanese company. Finger opening port and a closing port. So if you are pushing in air, basically you are moving inside piston to one direction, pushing it from other side, it takes off. So extension and retraction is happening inside. So what is there inside? So it will require a 5x2 way or 4x2 way valve, pneumatic valve to operate. If somebody is from automation can understand it. So you have to push air and vent out the other one, push from the other side, vent from the other side. So that is how it works. So yes, you will understand. You see inside it has a piston, a joint and two fingers. Needle roller, that is to create it smooth without getting entangled, right? When it is pushed, it moves like this. The mechanism is such that it is irreversible also. Piston can drive the finger, fingers cannot drive back with the same amount of force. So it gets self-locked when it is closed. So if it is closed, you cannot move it back. The mechanism is such. So you cannot push the piston back. If you try to pull out the fingers manually, it won't come out. Only piston can move the, once it is inside, once it is closed, fingers cannot open it up. That is the problem. Okay. So that is intentionally done. So air from bottom and top can drive it open and close. So that is angular gripper. This is an interesting mechanism, right? So you can have extension to this finger to hold different kinds of object. Fingers extension can be done. Extension can be flat, it can be wedge, it can be circular shaped, right? Two finger, quite adaptable. Okay. So now coming back to my slide. So this was the one. So you see jaws are open and closed around a central pivot. Sweeping and arcing motion is done. Jaw needs to move up and out of the way in a limited space. So it is for quite compact spaces. Okay. So second one tells you It was a kind of toggle gripper, the video that you saw now, toggle gripper. Pivot of the joy movement acts as a over centered toggle lock, okay, provides high grip force and power to weight ratio. Once it is closed, it cannot be opened of its own until unless you apply a reverse air pressure, right? So actuation can be done using electrical solenoids or pneumatic piston. Definitely it can also be hydraulic, but we do avoid that. We don't want that to happen, right? So maybe again I can come back to a small video. Watch this carefully. So how is it working? Actually, it is getting toggle locked. It opens up, but it is locked at either position. So once it is closed, you can make that object travel to long distance without risking that object getting coming out of its place, right? It shows the complete assembly. You can have an adapter to fit it to the robot. Finger adapter can also be there. Wedge type of adapter is shown here, twin wedge. Finger adapter or the robot. So these are the pneumatic connections which are there. Port A and port B. These are the flow controls. Flow controls to control the speed at which it opens up or close. What are these now? Any guesses? What are these? Just now it is fitted here. What are these? Any idea? Any idea here?
Sir, pressure sensor?
Not exactly pressure sensor. They are
Force,
sensors, right?
force
They are
sensors.
that detects the state of the gripper, if it is open or it is closed. Essentially, they are Hall effect sensor, Hall effect magnetic sensor. So what happens? Inside you saw there is a piston. If the piston is over here, you can see my cursor. If the piston is here, okay, so this will get activated. If the piston is down below, this sensor will get activated. So depending on the inside position of the piston has a magnet fitted inside. Okay, that magnetic field comes outside the casing and energizes this Hall sensor. So either it is open or closed. So state of the
So, sir,
gripper
they are
is
kind of
constant.
reed switches.
Not reed. Reed switch and Hall switch is different. Right. So reed switch has got two wires. Okay, it is just a magnetic contact which happens due to magnetic field. Okay, but in case of Hall, it is a kind of material which acts like a transistor. No, so you have supply and you have an output. So output is activated when it senses any magnetic field. Okay, so it works little differently. Okay, got it? So Hall sensor. Again, it is a magnetic field that energizes it. Okay, it is mostly indium arsenide, arsenic sulfide or kind of materials which are having that kind of property. Okay, so that is Hall sensor. See what else is there. So this was the piston. You see, piston position is sensed by the Hall sensor. Got it? Saw that? So this is a variable voltage. Depending on the position of piston inside, you can see the voltage. Percentage of valve if it is open. 1 to 10 volt it is giving. Industry 10 volt is standard. You need to mute if you are not talking.
Kindly mute yourself.
Okay. So you see the variable voltage you saw, no? So with just one Hall sensor, it is good. You can just measure the voltage instead of working in threshold kind of high or low. You can have a variable voltage to understand the percentage it is open or closed based on the Hall sensor voltage. Hall sensors are very inexpensive. Some 10, 12 rupees you can get in Amazon also. Okay, you can use that to understand your gripper state also. Okay. These are some external attachments for limit switch. You can have limit switch to show the state of the gripper finger. You see, these are limit switches, or sometimes proximity switches. This was proximity, it was not limit switch, it is proximity, so that there is no physical contact and no wearing will happen. So if this lever comes in front of the proximity switch, it tells, okay, this finger is open. Okay, both the finger state can be independently reported. You see, there are multiple ways to use it. Okay. So this is manual opening and closing. If at all it gets locked, so this special system is there so as to manually open or close. So many features are there, you see. You can limit the position, how much to open. So this is the limit you can put. You can attach an external bolt which essentially creates how much it will open, how much it will open. So that can be limited, or manual opening can be done using that hole. This is Fisto one. In the figure that I showed was a SMC one. Got it? Okay, hope you got it now. Okay, let us move ahead then. So this is a type of arrangement that you saw. You saw external arrangements which are there to detect the state of the switch, right? A state of the gripper fingers, right? So that is toggle gripper. Next is based on number of gripping fingers you can classify. This is self-centric or concentric self-aligning kind of gripper, three fingered. Each one of them has this kind of wedge shape over here. Okay. So that is to envelop a circular kind of object. If it is a circular object, it holds like this. Got it? So that is there. Individually servoed, it has many degrees of freedom. This is a kind of near biomimic hand. This is from Shunk, but Robot IQ also makes it. That these are very, very expensive. Until unless it is required, you should not use it. They are literally very expensive. I have in my lab three fingered gripper, each is something around 15 lakhs. Robot IQ. Okay, so it is literally, I am using it for dual arm manipulator, where each finger is servoed and you get feedback, it detects slip, and it has many features. Until unless it is required, you should not use it. In industry, just two finger is enough for lot of purposes, or maybe at the most three fingered simultaneous motion one, not independently servos. Okay. This is a kind of biomimic hand which is very, very dexterous. Okay, I will show you again a small video here. How do they look like when it operates? So it is very much like our own hand now. Each finger can be moved, it can envelop, it can pinch grasp, it can hold it, envelop it. So multiple ways it can do the grasping. Okay. So it is used for maybe a robot may or may not look like human, you know that, right? So until unless you need it for the places like child care, elderly care, or maybe in the space applications where you need to look like human too. Okay, to understand the psychology of a person in medical, normally we prefer having a robot which should look like human also, otherwise they may get traumatized or something like that. You cannot afford to look like a typical robot, industrial robot arm when it is doing an eye surgery. Understood? Even though doctors are around, you don't prefer it to have it, right? So that is the reason. So until unless you need to look like human, or maybe there is some special advantage that you are getting, otherwise they are expensively, okay, exorbitantly costly. Okay. Again, these can be independently pneumatically actuated, can have toggle arrangement, can be angular, can be parallel, electrical servo, or it is normally having rope drives. Weak field coupling is there. So what happens, no, there are kind of mechanism, I don't know if I can draw it here. So let me clear it a bit so that I can use this space to draw. Yes. So what happens now, let us say you have mechanism like this. I will draw some levers. So I have lever like this. I have a lever which is like this, another rope, and you have another kind of lever which is like this. This is rope, again it is pulled, this is rope, this is rope, this is rope, this is rope. Okay, I'll again draw it more closely now. Okay. So let us say you have 4 fingers. Okay, you have 4 fingers. Okay, what I'll do here, I'll just try to make the links like this. So this is link, this is link, this is link, this is link. All the red ones are ropes. So if you pull this rope, what will happen? It will pull this, it will pull this, right? Again in turn, it will pull this, pull this, pull this, and pull this. Okay, so let us say you have this 4 fingers which are here. Okay, if you pull just one rope, all the fingers will be pulled. Is it not? Yes or no? Yes or no? Anyone? If you haven't understood it, let me come back once again. So what I am doing, I am pulling this rope downward. This is a link, this is a link. It is pulling this link, it is pulling this link using these 2 rope. So which in turn is pulling all the 4 ropes, that is pulling this rope to close this. Okay. So if at all there is resistance in any one of the finger, any one of the finger is constrained, okay, it is not allowed to move, what will happen? Others will continue to move, right? So this creates a kind of enveloping grasp. So it can this using just one rope, you can create a kind of mechanism which can envelop itself. Let us say today it is holding a, what happens when you grab something, okay, it takes the shape of the object. You can hold a rectangular object, you can hold maybe a cylindrical object. So constraints are put to the fingers in a different manner. Okay, sometimes this gets locked first, this has to keep moving. Okay, then this gets locked, this gets locked, until unless all the 4 fingers are locked, this rope will keep moving. Okay, so that is the mechanism inside a lot of times. So this is a kind of mechanism, so rope kind of mechanism. This is very popular in creating multiple fingers so as to create enveloping grasp. Okay, so that kind of rope drives are there. So rope drives are very common in creating multi finger grippers. Okay, this is internal grasp or an external grasp. Okay, so again let me come to a video here. Okay, watch this. This is a kind of gripper which can hold objects of various sizes, you see. From internal it is able to hold it. From outside also it can hold. It can hold like this, squeeze it, right? It can do enveloping grasp so that while moving it won't fly off, right? So this is a kind of versatile finger design which can hold objects of various types, again by Robot IQ, which is very expensive. Okay, so you see it can envelop. So that is a common closing force as a common type of grasping, external grasping. That is the most common one. We hardly hold it from inside. Any place that you see you need to hold from inside. Let's say you want to hold a cooker, a pressure cooker. Okay, you can hold it from inside also. You want to move it from one place to other, holding it from outside.
ठीक है यार टारगेट फॉर
You
एमिंग
can
इसमें तो जो लिखा है
please mute.
Kindly mute yourself.
क्या बात करना किसको अरे क्या करना फाउंडेशन बनाना क्या बनाना है
Ravish Kumar, serious?
कल कर लेंगे
Ravish?
Yeah. So you see a cooker, no, if you want to hold it from outside, what will happen? You have to open up your gripper too wide. That is very difficult. Okay. So holding it from, and more so it may slip off while moving. The shape is circular. Okay. So that is the problem. So if you hold it from inside, it will not only require a small opening, rather it will avoid any kind of slipping while transferring. Okay, so that is the reason. So there are special locations where places where you need to have internal grasp, and that is more safer. Okay, a kind of adaptive grasping is shown here. So you see this is classified based on the internal or external gripping. Standard 2 or 3 finger may be used. In this case again 2 or 3 finger can be used. This is very much adaptive, you saw, due to the kind of mechanism which was there. It takes the form. So you see it is enveloping from outside. It is enveloping. So while moving at high velocity, due to the centrifugal force on this, it will not fly away. Okay, it is enveloping from outside also. It is a metal envelope. It is not just by friction. It is creating a physical constraint by some normal reaction force like this that holds it inside, so it won't slip off. So that is the beauty of having such kind of grasp. Okay. Now there are many other types of grasp like magnetic gripper. You saw the video also. You need to have ferromagnetic objects to do it. There are vacuum gripper also. Vacuum gripper which works on Bernoulli's principle. Conda gripper kind of. What is Bernoulli? Why it is used here? I'll show you a small video again. This is a multi-fingered gripper of various openings. This is of different type, this is of different type. So it is kind of tool changer which is also there. Depending on usage, it can use this one or this one, number 2, number 3 or number 4 one, and it can rotate about its own axis. Got it? So it can rotate about its own axis about this, so that it can change the kind of gripper which is in operation. Okay, so it can rotate and use different gripper. So multi gripper with tool changer is there. This is a specialized gripper which is made by Delex systems. Okay, if you press it hard, basically what happens, it is having a, if you have seen a bean bag, bean bag is a kind of sofa which is used nowadays. So it has many huge amount of particles inside which takes the shape of the body, and it can lock itself due to our own weight. While sitting, gradually it takes the shape. When you completely put your load, it freezes, okay, on that shape, and it becomes a same shaped sofa. Okay, so that is the way it takes the shape of the object, and it can hold anything. So it is exactly of similar type, but this is made even more firm this has got ferromagnetic particles inside, small particles. Okay, so you push it against the object, energize the magnet so that it becomes locked, all the particles will be locked to form this shape. Okay, it gets frozen and it can hold something. In order to unhold it, okay, release it, what you will do, you will demagnetize it and all the particles become free and you can loosen it up. So this is another very interesting method to do it. This is patented by Delec and it is quite good kind of gripper. Okay, again there is a good video that will show a bit of this, not Delec one. Okay, watch this video carefully once again. So this is a biomimic kind of gripper. What is there inside is compressed air that goes inside all the four bellows. Bellows are shaped in such a manner that if you compress it with, if you put in compressed air from the top, it changes its shape inward and it holds the object. So that is the principle behind. Again, it is patented. So you can, it is quite soft in gripping. This is soft gripper. So current day research is on this kind of gripper only. It takes multiple shape, right. It works on pneumatics, so they are naturally cushioned. You can attach 3 finger, 4 finger, multiple shapes, soft objects can be gripped, right. It takes the shape, it can do enveloping grasp, it can hold egg or anything. Got it. So you can nowadays, you know, you have 3D printer in your labs, you can 3D print and create one such bellow and try to push in compressed air to get this deformation and create your own fingers. So this is quite easy of a project that you can give it to your students to do it, and yes, it is very helpful to create your own gripper, soft gripper. Got it. So quite interesting, no? It is fitted at the end of a delta robot, right. Soft objects are getting hold, right. Okay, so now let us again come back to our slide here. So now gripper drives, you see, you can use pneumatics for smaller units. For smaller units, quick assembly, pneumatic systems are very fast. You know, you can push in a lot of air in just no time, right. They are literally very fast as compared to maybe a screw drive mechanism or maybe rack and pinion kind of mechanism, 4-bar mechanism. So they are literally very fast. High cycle rates, there are few parts only which gets weared out and can be easily maintained also. So that is pneumatics. Electrical motors can be used for high accuracy and repeatability. It takes less of a floor space. Pneumatic systems needs compressor. Okay, pneumatic systems need compressor, but this one do not. You can directly take supply from any wall mount. They are low cost, easy maintenance, that is electrical motors. Grippers can be very big. Hydraulic only in case when you need high strength and high speed because while moving an object, huge amount of centrifugal force comes up. Okay, so object may fly away, so that is to avoid that you need high gripping force. So in case of large robots, mostly we use hydraulic grippers. It takes floor space, mechanical simplicity is there, but yes, maintenance is more. It can create a messy surfaces due to oily nature. Okay, used usually with heavy payloads. Other various kinds could be your hook. Hooks can be used as a gripper also. Okay, you need not to have any kind of mechanism. You just have a hook, you hook it and take it somewhere. if at all that object is of that kind, it allows doing that. You can have even adhesives. There are adhesives which are used like a gripper. You can have rough surface also. You just slide it, put it into some bin or maybe something. From the conveyor you can drag off. You can have rollers, you can have pushing arrangement, you can have many other types which doesn't have many mechanisms, and still it can be called as a gripping device or end of the arm tooling. Okay. Now next one is various consideration that you need to do, okay, while you design a gripper. Okay. Custom finger, you just saw you can have shape like this, you can have shape like this, gripper shape, or you can have shape like this, or you can have just rectangular flat surface with some kind of rubbery surface over here. So there are many ways. So each of them has got its own application, advantages and disadvantages, right? Something that can open, you can create your own range. Your system allows moving by 5 centimeter displacement of the finger. So you can have an attachment on this finger so as to make it little more range. Okay, you can create finger of this shape on the top. So if this goes from 0 to 5, okay, this can go from 5 to 10. Okay, displacement is 5 mm, but it can be made little wider by using a finger attachment, right? So it can go 5 to 10, 10 to 15, 15 to 20, like that, with just 5 mm actuator. Okay. So that is what you can have, some external attachments on various size gripping force unit. Consideration what you can think of is gripping force, how much air pressure to use, how much electrical current should flow, what should be the mechanism, should there be any toggle locking arrangement, should there be an enveloping grasp or something like that. Encompassing means it envelops from outside. Some retention finger, third finger is required. Okay. Shape increases the stability, reduces the necessary gripping force. If you can envelop it, you can handle with less gripping force. You can have friction force as well. Okay. There are various sensors which are there. You can have Hall effect sensor to know the state of your fingers. You can have proximity. You can have tactile sensors to detect any kind of slipping. Mind it, they are very expensive. You can have magnetic switches also, and some protective covers. Sometimes gripper require cover. You know what, your whole of your IP is governed by the IP of your, it is not intellectual property, it is ingress protection, IP class. It is designated by, let us say if it is IP 65, dust and water protection. Okay, first letter denotes dust and second letter denotes the water ingress level. Okay. So that basically governs the IP of whole of the robot quite a lot of time. You know, you whole of your robot may be IP 65, but what happens when you are handling something, let us say you are doing paint spray, but your gripper is of IP 10 or something very poor. Okay. So your water ingress will happen in the gripper. Okay. As soon as gripper is flawed, whole of the robot being IP 65 becomes useless. Okay. Okay. So that is the reason. So you need to select your gripper, you check the data sheet so as to maintain the robot's compatibility to the environment. If the robot is designed for clean room, okay, and you are using the robot in clean room, you should select the robot gripper also for the clean room, right? So gripper can fail whole of the robot, so choose it very precisely. So protective covers are there. Let's say you want to handle some radioactive material, maybe you require some kind of lead shielding on the electronics which are there in the gripper. Okay, so that is the reason. So protective cover. So these are some of the design thing that you need to be kept in mind while you design something. Similarly, some standard design practices are like this. Number one is minimize the weight effect on the robot's performance. Let's say you have a robot that can carry, let's say, 1 ton capacity. Okay, 1 ton capacity. You have a KUKA Titan which is 1000 series. KUKA Titan is 1000 series robot, but you have to, it can handle something around 1 ton of payload. But to handle that 1 ton of payload, your fingers are very heavy. Your mechanism should be very strong. You have to have a very high amount of gripping force. So what will happen? You have created a gripper that itself is of 200 kgs. So now robot plus the gripper combined together can pick only 800 kgs. So bare flanged robot, when it is delivered, manufacturers say this robot can carry 1 ton of payload, that means without the gripper. So you may, if you tell you want to handle 1 ton actually, so you have to buy a robot that can carry more than 1 ton. That should include the gripper payload. So weight effect definitely will have a lot of performance issues. Moreover, if your gripper is widespread, it is having more moment of inertia, so that will have a effect on the robot performance. Dynamic performance will change. So you have to maybe have to do some kind of dynamic tuning of your robot. Load characteristics of the gripper should be taken care of while you are doing any precise task. So that essentially focuses, we have to focus now on the kind of material selection. You may have some kind of lightning. So your finger may have some holes inside to make it lighter and bigger, okay, and still bigger. So that is, lightning holes can be made. Materials is to be selected so as to make it lighter, okay, and the shape should be done in such a manner so as to have less moment of inertia. So these are few things, okay. Minimize the size, that helps definitely to minimize the weight of the gripper. Reduce cantilever load. If your fingers are very long, it will create cantilever load as well as moment of inertia, right. So if the fingers are very long, you need huge amount of bottom force to hold the same object. It definitely conflicts with the flexibility. If the fingers are long, definitely they are a bit more flexible also. So more of deformation can happen if the fingers are long. So minimize the size. Then comes the maximize rigidity so as to have more positional accuracy and repeatability. These are again related to performance characteristics. ISO 9283, that is ISO 9283, that is the ISO standard which governs the repeatability of a robot. If at all you have fitted a faulty gripper, it affects the repeatability also. So reduces the vibration, any kind of vibration effect. So maximize holding force, again reliably hold the part without damage, okay. You want to hold an egg, can you handle it? So I'll show you maybe a small video here. I don't remember which one was that. Yeah, this one. Just see this video. It is a parallel fingered gripper, but it can hold egg. You see? It is made up of a material like a balloon or something. right, a diaphragm kind of. So it takes the shape of an egg, and even though you have a tough surface for the gripper itself, it is able to do this. Okay. So this is what. So it can reliably hold the part without damaging. So you have to maximize the holding force at the same time. While it is holding, it should not affect the reliability of the grasp. Orient part to maximize force in the direction of motion. Now you saw you were able to reorient the egg, and still it can hold it reliably. Maintenance and form factor change consideration. Okay, gripper should be such that it is easy to maintain, and should allow robot to be maintained as well in easy manner, right? Form factor, these are few things which are for design consideration you have to check, right? There are various ways you have to select the gripper. Workpiece analysis, objects which is to be handled, weight of the object is to be taken care of. Process, you have to pick and place from and on the conveyor. So that is very easy, it is only vertical motion, but when you have to move in a circular way, your gripper is oriented so that object may fly off, it can come out of the gripper. Although the weight, let's say you are handling a 5 kg payload capacity gripper, you have a 5 kg payload capacity gripper holding a 2 kgs only, but while moving it creates a centrifugal force which is more than 5 kg, it may come out of the gripper. Okay, so process is very important. While moving, the dynamic forces are quite different. Friction also has got different effects in different directions, right, depending on the shape and material of the gripper fingers. So design consideration, something that you have considered earlier, finger design, that is the length, it cannot create cantilever, or it should not be flexible, it can create a cradle or a capture thing, it should be repeatable, gripper stroke, etc. These are the things. Type of gripper can be pneumatic, it can be electro-pneumatic or electrical gripper. So depending on that you have to check what are the issues there. Clean room is there, corrosive environment is there, high temperature, radiation is there, waterproofing is required, air quality, lubrication or non-lube, IP rating, ingress protection rating, all these are the issues which are to be taken care of. So, apart from this, definitely cost is a concern. Flexibility, sometimes it has some positive effect also, as you saw in case of egg holding, you need to have some kind of natural compliance in the system. Changeover, you may have a gripper which needs to be changed quite frequently, so end effector tooling needs to be changed, so you may require a kind of tool changer or something. Got it? Safety, loss of power and collision, what will happen? Gripper should not automatically open in case of power failure, right? Handling, sensing, so you have a sensing feedback also, open and close state. So popular industrial gripper manufacturers are industrial wise Shunk, ATI in India, it is dealt by Shunk only, although they are two different companies. Jimmer, popular in India, SMC Japan makes grippers in India also. Fisto, good manufacturer. Genetics, Indian Coimbatore based company who is making it good. Okay, Robotics, quite expensive, but yes, quite a special kind of grippers are there. Apart from this, there are quite a lot of grippers which are there in the market. You can always browse it through, but these are some of the standard makes. So yes, let us go through maybe one or two data sheet now. Okay, video catalog, technical data sheet, some journal papers. Videos we have seen plenty. I would like to show maybe one of the technical data sheet now. Okay. What all parameters which are there while choosing a gripper? Okay. Okay. Let me just share my screen, that would be better. Hope I can share my screen also.
Yes, you can.
Just a sec. Okay. So this is it. Hope you can see my screen.
Yeah, it is coming.
Okay. So this is a kind of pneumatic gripper, parallel and angular gripper. I want you to just see what is very important here is few of the parameters which are there, which are very helpful in selecting this kind of gripper. You see, stroke. Stroke means what is the lateral distance which two finger gripper can travel, right? So that is very important while selecting. So these are the parameters which normally a gripper manufacturer allow you to choose with, okay? Okay, and then you have a total gripping force in pounds. Parker uses pounds, but it may be SI system also for few gripper. So you see, gripping force, metric design, any kind of feedback is given in terms of metric units, right? Ball bearing construction, clean room construction, spring force is there. So for open or for closed. So that could be, maybe you want to hold it from inside or outside. So you need gripping force while holding from outside. So in that case, spring will open it up, pneumatic force will close it up while holding from outside. So spring from inside, a spring from outside. So that is what is here. That means you have a sensor, it can be reed switch or Hall effect, it can be proximity switch. Synchronous or non-synchronous. Synchronous normally both the fingers are synchronous. If it is closing, both are closing. If it is open, both are opening. Right. So it can be synchronous, it can be non-synchronous. One of the finger can be constrained and others can continue moving. So it can be of that kind. So these are few parameters, and then you have on the vertical side you see miniature kind of, it has some kind of automation, means it just gives you lateral displacement. Fingers you will have to attach. Low profile one, very compact, highly precise one, high force long stroke, you have to wide open, hold a pressure cooker, right? So you have a long stroke, right? And maybe you have a three jaw finger. So for three jaw finger, again stroke, gripping force, those things were important. This is three jaw, this is all two jaw. So this is kind of gripper selection you can do based on these few parameters, right? So angular gripper, again it has 30-degree opening or maybe 180-degree open, okay? Again clean room, dust cover is there, metric design, reed switch, proximity, all similar parameters are there, apart from you have angle to which it can open, okay? 30-degree, 12-degree, 180-degree wide open, right? So these are a few parameters you see, and then you definitely have some small numericals that can be done here. So what could be the length of my gripping finger to hold an object which is of this length? So what should be my gripping force, what should be the gripping torque, how much torque it generates? So those numericals are there here. Some solutions are given here which will help you to do select a gripper, okay? So this is for the Parker gripper you saw. This is for Shunk, which is again very popular in the industry, okay? So these are various kinds, nomenclature is there. Three-fingered universal gripper, three-fingered gripper for small components, two-finger universal, parallel grippers, long stroke grippers, universal angular radial grippers. So there are various kinds it makes again, okay, and it is in respective page number you will find, you can do that. Again similar parameters are there, stroke per finger, gripping force and torque, okay. So that is what is very important. Opening angle in case of angular gripper, gripping moment and torque, in case of angular gripper, right? So these are the parameters. So based on that you come to a model part number and then you order for that. So this is what as an I call it as an engineer's way of using a gripper, rather than just if you go to a market to buy anything, you definitely need to tell some specs, right? In order to put in a tender also, maybe you require to specify those specs. It is better you go through these data sheet thoroughly before you order something. If you are buying a robot, by default it doesn't come with a gripper. So to order a robot, maybe you have to specify the kind of gripper which is more useful throughout the tenure of the robot, because grippers nowadays are very expensive, at least industrial grippers, 1 or 2 lakh in addition to what robots cost is there. So it is better to plan an order so that it serves maximum of your task, right? So that is the reason. Okay. So this is was 2 data sheet that I have discussed. Maybe I will come to this now. I will stop the share. I will share once again. Okay. So now let me come to one of the, I have discussed the technical data sheet, maybe 1 or 2 journal paper, 1 or 2 my research that I want to put it here. So far you have seen all the robots they hold using end effector, right, end effector. But it can happen that you hold like a human. A monkey can hang from the tree just by using his tail, is it not? Have you seen it? Monkey hanging upside down from a tree using its tail. It is not using its hand or legs, right? It is not using its limbs, rather it is using one of the body appendages which is known as tail. Similarly, you can hold your cell phone like this. Is it not a gripping? Tell me, is it not a gripping? You do steering, you steer your car at the, don't do it, but okay, so but you can hold your mobile like this. You any body appendages can be used. That is what is human being is made for. You can fold a bed sheet just by holding like this. Can you see me thoroughly? You can hold with your teeth and you can fold it like this. You can fold it. Instead of using your dexterous fingers, you can always use your teeth, you can use your chin, you can use your neck. A football player can hold in between his arms. A cricket player may hold something in between his thighs, right? So that is what, you know, that is what is human. Human always supersedes in its action. So I had done one of the research, and recently I could publish in one Q1 journal, Robotics and Automation System, Autonomous System. That paper I like to show you. Okay. So I will share that paper, watch it clearly what I meant here. It will find some interest, some researchers definitely find it very interesting, because ultimately most of us wants to do research also, no? So that is my intention. I will just share my screen here. Okay. So this is visible. Okay. So what it says unconventional grasping in multi-limb humanoid using whatever control. Fuzzy logic I have used it. I have also used RL based approach to do this. Okay. So what I have done, see this kind of folding. Do you think you need grippers, fingers to do this job? You don't need it, right? You can hold just in between your elbow and your arm. This is one, holding a baby between both of your arm and the torso, right? Holding helmet between arm and the flank. You are doing it, right? You are doing it. Again, so this is one workout that I have done here. How many different ways one can hold an object? Head, shoulder, left upper arm, right upper arm, left forearm, right forearm, torso, thorax, left upper leg, right upper leg. So I have classified all the appendages and its subsections and create a table here what all gripping can be done and what cannot be done, feasible or not feasible, and that is normally done by humans. Okay, I made this algorithms to hold in these kind of ways. Okay, holding like this, holding over shoulder and head, holding it between your thighs, and see different ways you can hold things. Not necessarily you are using your fingers or your palm or your hand altogether. Got it? So that is the takeaway of this paper, and it is recently published in 2025 only, last year something around October. Okay, and this is a very good job that you can follow. You can continue your research from this place or maybe something in soft gripping. So these are my research direction that I can suggest to you while you want to do any kind of research. There is one more publication that can do assembly task not just by pure positioning. Okay, so that is one another publication. I will just show that. This is another publication which is there. Here what I have done, I have gripped using a two-fingered gripper. I don't know if I have shared it. Just a sec, I'll share it now. Okay, so this is a two-fingered gripper. Okay, it is held in the cobot. This is Kuka Aiva robot. I am holding it, but instead of applying gripping force and applying force to applying position control trajectory to search the hole, I have used force control trajectory to locate the hole. Right, instead of the way we do insertion in a peg in a hole task, how do we insert a key inside a hole? Do we see it thoroughly? You can do it. You can do it in case your vehicle is standing in the dark. What do? You just blindly go near to the keyhole, move around and push it. What you are doing? You are applying some force control, not a position control. You don't know the position. You know the forces which govern to that hole, right? So constrained force guided motion is used to insert in the hole. So that kind of gripping assist is done to insert this pellet inside this hole. That is what is demonstrated in this paper using a cobot, and this was quite good paper that also I have done, and we have recently worked on some gripping and assembling task using parallel and serial hybrid structure to do peg in a hole task, to take care of precise manipulation and long distance manipulation using serial is done. So this paper is all about. So these are few directions that I have followed. You personally can take up this, or maybe soft gripping, which is very popular. I wanted to show you a video here. Just let me see if it is here. Okay. Which essentially is on kind of a different approach altogether to do this kind of job, maybe a research direction. I am not sure where I will get it. I will share it. Okay. So anyway, so this is a course which recently is on cobots, which is upcoming course, my upcoming course, which is starting February mid. Okay, it is on collaborative robots, NPTEL course. Why I am discussing here? Because this course talks about compliance. Okay, why compliance is required? Because you want to hold something which is soft. So it will talk about, I have one publication which is on soft motoring techniques. Okay, how to create that kind of drive which can control force. Okay, because you have to control gripping force. You want to hold an egg, you may have to hold a sofa or something which is a variable shape. So that has to adapt to the surface. So that kind of control circuitry is discussed in this course, compliant grippers, compliant systems. So I'll talk about all this in this course. Definitely another course which is on industrial robot, which is finished already in last year. Okay, so this will again come in July somewhere next year, this year only. So these are the two collaborative robot course which is there on NPTEL that I teach. Okay, these are few relevant publications which are there. So the first one is this current sensing based controller for brush DC motor for robotic application. This can be used to create compliant electrical grippers. Okay, this is the one cobot task that I have shown, overlaid orthogonal based assisted localization and assembly. This is unconventional grasping, soft gripping I haven't worked on, that could be a good research direction, quite popular these days, right. So these are some special supports that I got from BARC to do nuclear pellet handling, that was made up of amorphous material, basically sintered radioactive substance to make those pellets, and that is to be inserted, that is polonium basically inserted in honeycomb structure. So that is that project was handled through BARC project, and I used this kind of approaches, compliance systems, to do this assembly. DRDO R&D Pune. So this is the current research I am working on. This is the project ongoing in our lab now, and that is at IIT Dhanbad. Okay, we are having two 7-DOF dual arm system. Okay, fitted on a torso. It's a dual arm biennial grasp we can do. Okay, total 14 plus 2 degrees of freedom. Both arms are compliant. It has that RoboTQ 3-fingered gripper on both the arms. So that is there here. IIT ISM Dhanbad for giving all those facilities to operate, IIT Delhi where I started my job on this, and some industry support especially from KUKA India, SMC Pneumatics, Genetics, Zimmer and Aduza Robotics. That is my own company where we do such things through industry. Okay, that is my own company where I work also as director. So yes, all the videos that I have shown is available here on my YouTube channel also. Some of my research you can see. Okay, thanks a lot. Thanks a lot. I would expect some questions from you all.
So thanks, Dr.
Can I show my lab here?
Sure. It will be good. Actually.
Just a sec. I'll just share my screen once again to show my lab here. So this is a kind of ocular robot system that is used for surgery. It's a parallel robot, 6 RSS kind. This has a revolute, all revolute joint on the top, spherical joint on the two ends. This is a ocular drug delivery robot. We have got Gayatri Technological Innovation Award for this, and we got 2 patents on this, few publication and 1 PhD for this. So this is job done by my PhD student in our lab only. Okay, so this is a 6 plus 1 degree of freedom ocular robot system. Okay, so similar work is this again. This is a standard Yaskawa robot, but we could integrate this to our PC based system so as to do research as well as UG PG teaching. Okay, so we use this kind of 6-DOF robot with some magnetorheological finishing arrangement on the top as an end effector tooling to do polishing thing. So that is current going research by one of my PhD student, myself and Professor Jafar here. Drones are always a favorite of UG student. I don't do much research on this. This is for UG fun only. This is modular manufacturing system we have in our lab, which shows all kind of pneumatic arms and conveyor system, various sensor integration through different PLCs, different stages. It is just like an industrial automation system. My lab look like this with industrial automation here, actuator training setup, sensor training setup, ocular robot setup, drone systems, humanoid here. So our institute is the only institute in India which has industrial level humanoid robot. It is the only institute, and this robot is worth something around 2 crores. 7 of arm, both cobots. Head has got 2 degree of freedom as well, right? So it's a unique lab. This is 6RS platform built by my student only. It's a moving chair. I'll show you a video also. So this is how my lab look like. It is state of the art, best in, if not best, at least in Eastern India I could say. It has all sorts of things. So if you are interested to do research, come as intern or send your student as intern, you are welcome. This is pneumatic, electro-pneumatics and PLC training system that is there. Automation system. This is my student's desk. How does it look like? Internal library we have. This is actuator training setup. In this setup we teach students, this is a custom setup made by us only. So this is DC motor, BLDC motor, stepper motor, industrial synchronous, AC servo motor, induction motor. All 5 types of motors can be integrated to a PC based control system through EtherCAT. So all is industrial here. You see all the data acquisition system and controllers and IOs are industrial EtherCAT based system. This is industrial PC, industrial HMI. Okay, so whole of the system, we don't use Arduino in our lab. We don't use NI DAC, we don't use MATLAB. So what we use is open-ended system like Python, C, C++ to do all sorts of programming, and all the input-output systems are all industrial. Same with sensors. Different types of, we have bucket full of sensors, all kind of sensors are here, like you see this is force sensor, temperature sensor, LVDT, proximity, right? So all sensor integration is done and it can be pushed to in the IoT based system. You have a small HMI here again with industrial PC, right? So these are sensor and actuator training setups, fully custom built in our institute. So we have made so many robots, apart from we bought a few like Yashkawa. So even this one is a custom built robot. This humanoid is a custom built robot from DRDO, Soya Robotics and IIT Dhanbad. Okay, so it is it. So this is what we are doing in our lab. So feel free to come here. You are invited. Right. So this is how my lab look like, and maybe yes, and my team. And that's my team here. If you can see this, all our UG PG students are director and all our team, right? So this is a culture here. Families do come to the lab, we do party together, right? And I can show maybe a small video again to show what goes on in our lab. I am left with few minutes, so I am showing this. Maybe that can attract few PhD students, no? Yes. So this is it. So this is a humanoid robot we have. So this head is moving. It has a 3D sensor. It creates a point cloud, RGBD camera, industrial grade. Okay. This is the arm, left arm, right arm with grippers, robotic 3-fingered gripper, right? So this is our humanoid robot, half humanoid you can say, right? So you can do all sorts of research tasks. We are given this one to do DRDO research kind of. This is 6RSS platform, revolute spherical 6 of parallel manipulator used for simulators. built by my PhD student Himanshu, right? It can do all sorts of motion again. Again, you see this platform is built fully by my student. It is having HMI. It has all industrial grade servo motor, industrial gearbox, twin cat based communication system. All the wirings, each and every wiring is done by my student. You see the amount of effort and kind of learning they have it. It is not Arduino based toys that we do in robotics, right? We deal with all industrial sensors, industrial actuators, industrial system and integration, and no Python, no ROS, right? Even ROS we avoid using it. We build things from scratch, right? So that is our approach. So this is kind of quadruped we have made in our lab. Again, it was part of our research for one of my projects, right? Quadruped robot, humanoid and self-balancing robot we have done. So these are the researches that we do normally in our lab. Slow static walking, earlier was dynamic walking. It has to go under the table, so students they enjoy doing few things actually. These are for fun only. So this project is over now. So this is the ocular robot 6RSS platform. This is how it works. So this whole UI is built by mechanical student only, my PhD student. This robot was built by student only, again as a part of his PhD research. So every PhD student they built a machine, they build one machine. So this is a precise machine. So remote center point is being tested. So TCP motion. So it is used to deliver drug to the eye. Okay, we have tested on goat's eye, and this is turning twisting mechanism which is there here also. This is the kind of Delta robot. We closed this project with Genetics India. We made, and it has a vacuum gripper. Vacuum is created by Bernoulli's principle. That is what was Bernoulli's principle I was telling. Okay, so yes, vacuum is created by this. So let me just come to that. How that works? Basically, if you flow through a throttle, what happens? You create a partial vacuum at the center, at the high flow area, and that is what is used to create this vacuum. So vacuum also is created by this only, using compressed air. Got it? So this is vacuum created using partial vacuum, that is through compressed air. Got it? So this is how, and then you see this one I was showing. This is a vacuum created by using compressed air. It has silencer and it can hold anything like this, a paper. It has a tool changer that you can see. So multiple gripper of different sizes are there to hold different things. Compressed air to create vacuum. So basically a venturi is there to create a vacuum, but it is quite noisy, so you need sometimes silencer at the end. Got it. I won't go further here. This was just, I missed it, so I showed it. I'll stop here. That's all. Thanks a lot. So if you have any query now, you can please come in.
Thanks, Arun, for the nice presentations on the grippers. Lot of information you had provided to the participants. There are some questions in the chat box.
Yes, I'll take them up one by one.
Yeah. So, are you working in dielectric elastomer actuators?
No, not as such. Good afternoon. Yes, sir.
When somebody is asking, he's interested in your lab, so
Definitely,
what
you
type
are
of
welcome to visit it. I can make arrangement for your stay definitely here in the guest house, definitely in paid basis. But yes, you will get place to stay at least. Okay. Pneumatic lines. Yes, pneumatic lines are there. What is pace men game type gripper design? I don't know. I am not into actually gripping. Mostly I am a user of gripper. Due to my diverse experience with multiple types of gripper and the compliant technology, I am aware of these things. Okay, I am not a gripper researcher. Definitely I have done that multi-limb grasp that you saw now using body appendages. So that is area of research. That is my area of research, where I am using not just the gripper end effector as a gripper, rather I am using my body parts to hold something, right, internal or external. So that is the area as an intelligence I am using it. Okay. Please send me the PPT. Definitely, this whole of this PPT is already online. In one of my NPTEL video, if you go, it is already there online. This is from one of them only. Okay, if this is recorded, you can definitely share it to the user.
Yeah, we had recorded it, so we will
Very
be
good,
sharing.
very good. You can please share it with me also.
Yeah.
Dielectric elastomer actuator. No, I am not working, but definitely you can create one. I have seen few papers which reports creating one. That's awesome. Is there any kind of training program in your lab? Definitely we do hold quite a lot of workshops time to time, or maybe you can come here as an intern and definitely you can do some research maybe for a week or two during summers this year. A few faculties, they also came here earlier from various colleges in south, and COEP also came, and they have done quite good work here. Because my lab is not on traditional approaches of academics, we are bridging that gap. No, you saw our lab, it is mostly on industrial actuator, industrial sensor, industrial systems. We don't use Arduino. If at all we need to use microcontrollers, we build our own PCB for using microcontrollers. Maybe it is Arduino compatible, but it is not Arduino's. Okay, my students don't use jumper wires, double-sided tape, cello tapes, Arduino boards and ROS. 5 things are banned in my lab, and still we do robotics. LabVIEW is not used. NI DACs are not used. Can you imagine? If you take away these things from academics, research goes to halt. But that is very expensive, I tell you. Industry never uses it. Industry
Yeah,
never
they
uses
are only for the academic purpose actually. They are.
So industry should not end up in hangover actually. It is ending up, no. So finally it is not catering to industry, and students are not able to build their own products. Can you sell a washing machine with an Arduino board? Definitely it is doable, and much simply you can do it. You can control a motor using motor driver using Arduino also, but has it ever come to your home with that? Or maybe an AC came with a ESC controller or a BLDC motor driver? No. Why? because you cannot claim to make a product which is rugged and create something which is worthwhile. So academics are ending up nowhere because we are used to use this Arduino boards, Arduino compilers, IDEs, which are of no use, Python or maybe sometimes ROS. It appears you can do good research, but it won't end up making a good program which are worthwhile for industry. Industry never uses ROS, is it not? That is the reason, means that is the way we are practicing not to use 5 things and still do robotics. So that is our first principle. It's an industrial robotics lab, and that is all is my course is also about. My cobot course as well as industrial robotics course, it is all about that. I would suggest you go through these 2 courses that I have mentioned. This one is going to come just start this week only. February 15th it will start. So that is a collaborative robot course, no? This one. So you can do suggest your students to take up this course. It is very good. So all the intrinsics are covered. Okay. Next upcoming works. Yes, you have already joined. Offline is there. I think it is an NPTEL archives. You can get the offline videos of all my course. And my YouTube channel is hosting all the videos. You can get all the videos on my sites, on my YouTube site. So that link I have given here. Yeah, this one. If you just Google around, you can find me. So yes, I think if at all there is no other question, we can end. Please suggest how an electronic student. See, there is nothing called as an electronic student. You were a scientist first, is it not? When you started engineering, you started with science. So be a scientist, don't call yourself electronics engineer or a student. A student is, you have to see many things before you end up calling yourself a specialized one. As a UG student, you are not specialized. As a robotist, you are never specialized. I, being a mechanical engineer, I am programming, I am designing my own circuits, I am working in industrial mechatronics things. So you cannot say which branch you are in. So that is what is to come up from inside actually. Initiate process of making robotic arm. If you have to make it, make it. Who is stopping you? You start somewhere. You start somewhere and you can do it. You have to start it first, no? Until unless you start doing it, automatically path will come. Wherever you are facing any problem, you let us know, let your peer know, no, they will help you. You have to start it and you need not to specialize. You be a master of everything and start it. I am sure you will make one. We are making one. Actually, all my projects have ended up like a products. So company which I am running are mostly my student projects. All the YouTube videos are very professional. Projects should look like a product. That is my tag actually. Your project should look like a product first, so that you end up like a product, right? And have good practices, engineering practices. I have few lectures on my YouTube video on engineering practices for robotics. That I gave a talk at NIT Surathkal. That video is recorded and it is there on my YouTube channel. Please watch that. If you don't use Arduino, what do I do? Go through my video lectures online and you will follow our principles and definitely that will end up quite well. I have my own company running based on this principle, right?
So
That is what.
excuse me, just want to ask how the industry they're designing robots now, and what are the things going? Can you discuss something about this industry level works, how they are doing now?
See, mostly all the industrial robots, no, industrial robots, they are running an OS. Sometimes they are embedded OS like Yashkawa, or sometimes KUKA, they use KUKA Industrial Robot Germany. They are using standard Windows IoT version, Windows IoT. On top of that, they run with RTOS, real-time operating system, called as VxWorks. That a real-time that synchronizes, uses your dedicated clock for real-time synchronization. So these are various approaches. Either you use embedded, which runs only that program, nothing else, no parallel processing, nothing, or sometimes RTOS. Sometimes I have even seen systems like Beckhoff. Beckhoff systems are PC based control systems that uses TwinCat based system, that again locks your few of the gigahertz clock and does real time. So if you have a 5 core or 6 core processor, you can block 2 cores only to do real time work, and rest 4 does the time sharing work. Okay, if at all you are running MATLAB and TwinCat on the same system, MATLAB runs on 4 processors, 4 cores, and 2 cores are reserved to do real time clock synchronization. You can define path, you can define trajectory. Path is different, trajectory is different. So all robots are trajectory defined, not path defined, and that is done using real time clock system, right? So that is the approach basically, software wise. Hardware wise, definitely most of the industrial robot you see, it has a very poor architecture. They are still running on i5 systems, and it works quite well because they do only what they do. Their cores are dedicated. They are using embedded approach to do processor programming, like antivirus softwares and all they are doing, right? Please suggest electronic, if possible, make a robot that can replace human. Nothing can replace human organ. So far, researches are on, good videos are rigged up, I tell you. It is no more liver, artificial liver or kidney. People are working on it, but quite lot of videos are cooked up videos. Real research is quite far off now. That is what is my feeling. Quite lot of nowadays are AI generated. You won't believe, actually 90% of them fail to actually prove it. Go through the papers, what papers are published. Don't just watch video and believe anything. Right, now it is an AI world, it can show you anything. Be very careful. Okay, so that is what is my take. Honda Japan has done what quite lot of recent researchers are reporting now in your humanoid researchers. Okay, humanoid, you see Honda has done stair climbing, stage walking, handshaking, interacting with human long back, even when AI came into picture. In 2002 or something, it has finished its chapter. And now whatever you are seeing is just an extension of that. Honda was the first company who did it, Japan. Humanoid was done and called it over. Then some mockery came, like Sophia, which was there, which was given UAE visa also. That again is a marketing gimmick. And again now this quite lot of cooked up videos are there. Boston is real. Boston Dynamics is doing some real stuff. Very few are real. Even Boston failing videos are more than success videos. But they publish failed videos also. Others won't. Okay.
Hello,
Okay.
sir.
Yes,
Sir,
yes.
sir, one question, very silly question. So, how this name come from Aduja? So, what is the basic philosophy behind it?
You know हिंदी?
Yes, sir.
हाँ, हिंदी में अदूजा को क्या बोलते हैं? अदूजा. अदूजा
तो
मतलब
दूसरा नहीं हो, मतलब इकलौता हो जो सर.
यूनिक है ना, यूनिक.
Yes, sir.
But my name is ADU, Arun Dayal Uday, right? And I have my co-founder and director Jafar Alam. So it is Aduja. Got it? So it has two names, Aduja, Aduja. Otherwise it could be Jadu, Jadu. If he comes first, I come second, it is Jadu. So together we are doing that. Got it?
Got it, sir. Thank you so much, sir.
Okay. So please
Okay.
join my course. It is coming up next. Encourage your students to do it, right?
So
Make it
thanks.
yeah.
Yeah. So thank you, Dr. Arun, for taking out time and delivering a very nice lectures. Lot of information. Thank you very much.
Thanks a lot. See you then. Bye bye.
Yeah. See you. Bye.
Share the video, please. See you.
Yeah, I will share. I will share it. Right.
Okay.
So yeah. So participants, we are breaking for 10 minutes and then 5:15 p.m. we will be starting again the next session. That is the lab session basically.